Hello guys, and welcome to our daily Leetcode challenges. Let's begin today's Leetcode question, and that will be 2348, number of zero filled subarrays. Okay, given an integer array nums, return the number of subarrays filled with zero. A subarray is a contiguous, non-empty sequence of elements within an array. All right, so let's see. We have a array, and we have certain sections of the array that are of the value 0. And so a given integer array, return the number of subarrays filled with 0. So that would be 1 and 2, I believe. However, the output is 6. Is a subarray contiguous non-empty sequence of elements? Oh, so would this be 1, 2, 3, 4, 5, 6? Let's see the explanation. There's 4 occurrences of 0. The single element 0 as a subarray. There are 2 occurrences of doubled as a subarray. Okay, so that makes sense. So it's going to be a combination of these two. Sorry, not a combination. It's going to be, yeah, so it's going to be like you decide how many times you can create a contiguous subarray out of the given number of zeros, and then add that to the total sum. Okay, this kind of makes sense. For this, I'm thinking that maybe there's something called the, let me see, it's called the triangle sum. Triangle sum. Okay, something like this. Yeah. So the triangle sum, when there's the series of 1 is going to be 1, the series of 2 is going to be 3, 3 is going to be 6, 4 is going to be 10, and the way to calculate this number is going to be n times n plus 1 divided by 2. Or yep, so that's actually what we're going to be using. So in the case that we have a 2, that's actually t2, and t2 is equal to 3. And then when we're looking at this one here, this is 1, 2, 3. So t3 should be 1, 2, 3, 4, 5, 6. T3 should be 6, and that's what we get. And it's called the triangle number because you can see it sort of forms a triangle. There's the original number of elements, and then there's one less, and then there's one less than that. It's basically 1 plus 2 plus 3 up to the number that we've decided. So okay, so how do we do that? Well, we can just basically we can start looking through this array, and maybe keep 2 pointers, a start and an end. And while we're keeping this pointer, start and an end, we're finding where to leave the tail, the end, and looking at the next, looking at the next point to stop the start. So for example, we see that this number does not follow our need of being a 0, so we move both the head and the tail on to the next element. The next element also doesn't help us, so we move on to the next. Here we leave the tail, and then here we are just looking at the head, so since it's 0, we still increase the head by 1. At this point, we are leaving off the head and doing a head minus tail, and then using that formula before, the n times n plus 1 divided by 2, to add to the result. So let's have a result. Let's have a start. Let's have an end. And now let's simply iterate through all the numbers in the array. So for I in range len nums, we're going to say if, let's have an n, if n nums, if n is not equal to 0, then we simply advance both start equals I and end equals I. Else, in the case that we have encountered a 0, we're actually just going to only advance end plus equals 1. Okay, so we only advance n plus equals 1. However, so let's say that we are using this as our input array. Let's just think about how start and end will move. Start and end are pointed here when I is equal to 0. Start and end are pointed here when I is equal to 1. Start and point is pointed here when I is equal to 2. At this point, start is pointed at this, end is pointed here, and at this point we have to not only update and start updating end and start to be pointing at the same thing, but we also have to make sure that we add to res our L, which is, let's say, end minus start. And then we simply just, what do we say? Okay, if L is greater than 0, then we say res plus equals n times, n times n plus 1 divided by 2. And that's it. We should be able to submit this. And we're getting a wrong answer. Why are we getting a wrong answer? We're saying that the output is 13 while the expected is 6. The output is 13. The answer is okay, so this is correct for sure. Am I doing something wrong while iterating through the array? Well, I'm only going from 0 to 8, only 0 to 7, and each time I'm getting the correct n. So for example, if n does not equal to 0, then I calculate, then initially I ignore this because start and end are equal to the same actually element, but then I just update start and end to equal I. Let's see, what happens when what happens when I encounter this number here? I'm going to update both start and end to here. But then when am I doing something wrong with, I am. I'm not, start isn't actually pointed to here. Should I be doing a -1? Sorry. Let me just quickly think. What am I feel like my start and end index are off a bit. Is my logic here correct? That if n does not equal 0, then I just advance I to, should it be I plus 1? No. It should be a lot more simpler. I'm looking at this and I'm advancing to this one. I'm looking at this and I'm advancing to this one. I'm looking at this, I'm no longer advancing start. I'm looking at this, I'm not advancing start, but I'm advancing this. And then when I'm looking at this, okay, so my start is going to be here, my end is here, but that's still 2, right? Let me print this. Let me print this here to kind of see if my, okay, 2, 2, 2, 2, but my output is 13. What am I? Okay, so res. First time res is supposed to be 3. Second time res is supposed to be not problem with code, problem with execution. I named this nums, and then I am for some reason adding nums, not L. That's because I never meant this to be nums, and in the formula that I read, it was called n. So I'm actually just going to change this to n, and this is going to run fine. This is going to run fine with the exception of this. Why is this not fine? This is not fine if I'm guessing that a trailing 0 isn't going to actually hit this case of n does not equal n does not equal okay, so can I do this? Or nums I does not equal 0 and wait, can I just do this? Or I is equal to len of nums minus 1. But then I'm just gonna add this twice. Okay, so I actually have a pretty interesting trick here. I can just say nums append and an integer that doesn't follow my that doesn't follow the case of the 0. So this work, and sweet. Okay, that works. However, wow, this is not fast at all. Is there? Okay, so I've been thinking of maybe another approach to this. Let me go back to triangle number. The triangle number. Do you see how for each one of these numbers, right? For example, just look at the green ones here. if we were to be looking at the first row, we're actually adding 1. The second row, we're adding the first row and the second row. The third, we're adding the first, second, and third. And the fourth, we're adding the first, second, third, and fourth. So what that kind of mimics is us iterating over the array of zeros, of the subarray zeros, and continuously adding the number of zeros that we've currently encountered. Here's how I'm thinking we could do that. I want to current 0 count to be set at 0, and let's do for c in for n in nums if n is equal to 0, then I say current 0 count plus equals 1. Let's see, and then else if it does not equal 0, I reset the current 0 count to 0, and then just constantly, without any sort of check, I just add current 0 count to res. Let's see, res plus equals current 0 count, and let's have that not be misspelled. Return res. So if we're thinking of this triangle number, right? Let's have this guy here. I'm going to print. Okay, so the first iteration we go nothing, nothing, 1, 2, nothing, 1, 2. Except here, and now the sum of this, because we're first adding 1 and then adding 2 to the res, it actually looks like this. 0, 0, 1, 3, 3, 4, 6. And there we go. That's our 6. I hope that this visual kind of demonstrates that we're just counting the number of occurrences of zeros and then adding that to some res. Let's see if this works. Okay, current. Did I misspell that again? Variable reference before assignment. Yes, that was misspelled for sure. And sweet. Okay, faster, but still not that fast. Are they okay? So they're using files. These guys aren't using files. If it is some weird math stuff, then okay. So 0 filled subarrays, co and ants. For j in nums, if j is equal to 0, then co plus equals 1. Else if co, I don't know that notation. CZ ants current 0. If num equals 0, then plus 1. L if num does not equal 0 and CZ, I'm going to how is this faster? This is the same thing that I was doing. This is the triangle sum. This is the triangle sum. Oh, and I didn't need to do start and minus. I just needed to keep track of the total. I'm pretty certain that Pretty certain that just rerunning this, no, does absolutely no good. Okay, well, how about this? The solution with 87% beating rate. Hope that this is visually appealing. Yeah. I'd suggest using something like this. Okay. So yeah. Thanks for watching and see you later. Bye.